saw this one this morning, so the only thing I will add, as it's an Agile session, is that so far, the people who've come to my foundation level Agile extension training have got a 100% pass rate in the certification exam. So if that sounds exciting, you can, which is the laser button, it's that one, have a look at the website istap.eu. That syllabus, though, doesn't say a great deal about metrics in Agile. It just gives you a long list of some that, well, or some of them might be useful. There are numerous misquotations and misattributions of this, but I believe that is what Tom DeMarco actually said, and I totally believe it. I'm a great fan of metrics. However, there are some people who get a bit too excited about them and try to measure everything in sight, and that's not necessarily a good idea either. People just capture numbers and think they're metrics. Well, no, they're not really. They only help you if they're put in context. If somebody says, I found 40 bugs today, I don't know if they were really serious showstoppers or just spelling mistakes. I don't know if that came from 3 tests or 200 tests. So that sort of number really doesn't help me to manage testing at all. You need context. Data, in fact, is usually not information, is it? Information is only the result of processing data. And the other thing you have to remember is that metrics create work. Capturing metrics creates work. It costs time, it costs money, and it's not something that most people generally like doing. They'd rather get on with developing and testing. So we need to be a little bit careful about the metrics we choose. Yeah, and not waste money collecting metrics that don't actually help us. Now, in sequential life cycles, there's a fairly traditional list of metrics that we capture, and many of them are about progress through the stages of test preparation. And then, whoops. Sorry, mine works a little differently, so I'm not used to the buttons on this. Right. Okay, and then when we get into test execution, we're typically interested in things like how quickly the defects are fixed, where they are, how good they are, and whether our environment is giving us the service that we need. That's the sort of stuff that you'll do in a large sequential project or a RAD project with perhaps a 6 to 9 month iteration. Agile, of course, is different. Things happen much faster. A story might be done could even be done in half an hour if it's a really small story. So quite often, things happen before there's time even to measure them. And certainly they'll have finished by the time you've understood what the measurement means and tried to do anything about it. So that rules out some of the metrics that we use still use when we do sequential projects. This applies also to metrics about defects at certain points in the Agile project, because when people are working together on delivering a story in a feature sprint, we don't let defects pile up. They are fixed as soon as they're found. Most of the times they're not even reported. They don't need to be. People just deal with them immediately. So there's not much point in trying to count that. And yes, you do still have test levels in Agile, but they tend to be notional rather than prolonged. And even at component integration level, if you are running a continuous integration pipeline, any defects you found are going to be fixed almost immediately by the whole team. They will stop until it's done. That's how it's supposed to work. So I can't remember exactly where I found this. I have a feeling that it might have been in an article on sticky mines, but when I tried to look for it again, I couldn't find it. But when I first saw it, it looked good enough to me to make a note of it. Some thoughts from Elizabeth Hendrickson on things that really aren't useful. And I agree with all these. There are 4 of these. I agree with them all within the context of testing an individual story in a feature sprint. First thing is, if you're working to a strict definition of done, which includes testing to clear acceptance criteria, then when you say the story is done, your requirements coverage must have been 100%. So there's no point trying to measure that. Again, test pass-fail rates aren't very useful when tests are being, when problems are being fixed immediately and tests are very, very quickly being got to the passing state. For the same reason, counting the defects you found at that stage isn't very helpful. They don't tell you very much. And very often people just don't bother to record them because there's no real need to. This one is a little bit more contentious, but still within the context of testing an individual story in a sprint, I do agree with it. Just get them fixed, because you know they're fixed when it's done. And another aspect to this is that the whole team approach is absolutely fundamental to good agile working. And if you try to measure testing activities separately from the activities of development and business input whilst you're developing a story, you're actually creating a division between testers and the other team members, which will disrupt that collaboration. It can actually be harmful. That doesn't mean that we're not measuring testing in other ways, though. Some of the whole team metrics that we collect give us a very good idea of the tester's contribution. Velocity, for example, the amount of work that we actually deliver during a sprint. The testers are contributing to that. If you're measuring lead time, as well as or instead of velocity, again, you're measuring the tester's contribution as part of that. And the same applies to the performance of your continuous integration pipeline. So we are looking at the testing contribution, even though we're seeing it as part of the whole. Now, as I say, those remarks apply to the development of individual stories within a sprint. But of course, that's not, if I can put it this way, the end of the story. Because usually, towards the end of a sprint, we do some regression testing. Might be the last day or two. And that's when things start to get a bit more interesting from the point of view of the metrics fanatic. We want to start knowing now about what sort of regression bugs we're getting. We want to know how many, what kind, where they are. Because if any particular aspect of that looks to be too big, then it's something we need to investigate and do something about. And then, of course, Agile isn't just about feature sprints, as the previous speaker, I believe, although, of course, it's I was struggling a bit with the language, but I think made quite clear. There's a lot more than just developing stories. We've got to put them all together and make sure that they actually provide a solution. Now, in this particular example, there were 3 feature teams working in parallel from a common product backlog. And they did 3 sprints each of 2 weeks. And then the testers who had been embedded in those feature teams came together as a traditional test team for 1 week of hardening. Some people call it a hardening sprint. I've also heard it called a stabilization sprint. But the focus here was on end-to-end system testing, business process testing, user acceptance testing, and performance testing. And that was supposed to happen in 1 week. And during that week, the developers would be dealing with technical debt and perhaps having a bit of a rest. Well, let's just go back there. I said that hardening was supposed to finish in 1 week. It had been taking 2 or 3. Which is when the project manager, who was somebody I'd worked for several years previously, called me up and said, can you come in and have a look at this, please, and tell us why? So, as I usually do, I started measuring things. But the first measures that I put in place were things which I felt would help the team. During the hardening period, there were 2 stand-ups every day, morning, early morning, and late in the afternoon. And every morning I showed them this. This was basically the team's work for the day. And it actually happened that the teams were named after colours: red team, green team, and blue team. So that pie chart worked out rather nicely once I'd worked out how to adjust the colours in Excel. And I was only looking at the top 2 priorities because we had a rule that anything that was less than priority 2 was not going to be fixed until the next release. That was deferred. Then there was something else which I showed them morning and afternoon, and that was basically the progress towards clearing that backlog of bugs. And if it looked like that, it was supposed to be good for their morale. And if it was going up to the right, then it was telling them that they really had a lot of catching up to do. And they liked that. They felt it gave them a nice, clear picture of what they had to do and how the overall workload was progressing towards finishing the hardening. Then I started collecting some metrics that was giving me an idea of the overall process. So this wasn't about day-to-day working. This was about looking at what was happening during these hardening periods, bearing in mind each of these hardening periods was, well, there was one every 9 weeks, each of which was supposed to be the last thing before a release, and the releases were, these are the names of the releases. So this was the very first release that I was involved with, and you can see that it was a little bit messy because we came into hardening with a lot of bad bugs. Now that was not supposed to happen. But looking at that told me that what was happening was that the regression testing wasn't being done in the feature sprints. The product owners were cramming so much functionality, so many new features into the feature sprints, that in fact the regression testing was spilling over into hardening, taking the first 3, sometimes 4 days, and the work that hardening was meant to do, the end-to-end testing and the performance testing, just couldn't be done in only 1 or 2 days. So when I saw that, I realized why hardening had been taking too long. And drawing this picture showed me and everybody else that the process improvements that we put in place to stop that from happening and get the regression testing back into the feature sprints, or particularly into the end of the 3rd feature sprint, was actually working, because we went into the next hardening in much better shape. And although the overall height of the histogram looks like it got worse, actually it didn't get much worse, because the only ones we had to deal with were the 1s and the 2s. So they stayed at a fairly low level. So that showed that the process improvement was sticking. So that's an example of the sort of metrics that you can use to see whether or not a process improvement is working. Then I also wanted to know what kind of shape we were in coming out of hardening and going live. And here again, we had a fairly good picture. The first one wasn't very good, but after that, we had no priority 1 bugs. And this was useful to tell the team that they were now doing a much better job, to tell the management they were that we were doing a much better job, and also to give us any early warning if things started to get worse. They did get a little bit worse in that final release there. Because it was the final release, the product owner crammed as many features as he possibly could into the 3 sprints. So that's why it got a bit worse. But by and large, it was showing us that the picture had stabilized at a fairly good level for the priority 1s and 2s. I also wanted some idea of the coverage of the regression test suite. I wasn't interested in the exact numbers of tests, although I had to measure those to get the picture. But this was really a sanity check. I also had in my mind a picture of the relative size of each of the functional areas in terms of the amount of functionality in each. And I could see how that was growing as stories were being added release after release. That picture gave me a sanity check as to whether the regression test suite was keeping pace with the increased functionality. It's also an interesting lesson in how numbers can be misleading. You'll see that right at the bottom, the brown area gets a lot smaller, and you think, oh dear, what's happened? Has my regression test suite shrunk? Well, actually, what had happened was it had been rationalized, and although it had fewer tests, it was actually much better than it had been before. So there's an illustration of how numbers can be misleading, and you always need to go and investigate the context. Finally, the environment. During hardening, it was apparently an issue. The testers were complaining, but nobody believed it. And I thought, okay, nobody's going to believe this until we actually come up with some numbers to prove it. So what I did was I plotted the total number of days that hardening took, and that's the top of the light blue area. I also plotted the number of times when the environment was down. The light brown is when the back end was down, and the dark brown is when the front end was down. So then the depth of the light blue area gives you a very clear picture of how many useful testing days we had during each of those hardening periods. The purple area actually superimposes on that the number of defects that we had to deal with. And so I was able to demonstrate to management that the length of time hardening took was a function both of environmental availability and the amount of defects we had to deal with. Now, you'll probably all think that's extremely obvious, but a lot of people there didn't. They didn't have enough knowledge of what testing is all about to realize that until they saw the picture. And when they saw that, they began to take the environmental problem seriously, and you can see that soon it got a lot better because I was able to prove it. And then, of course, I was very interested in the number of defects that got into production. I measured that from the day that a release was deployed until the day that the next release was deployed over the top of it. And I'd intended to calculate defect detection effectiveness from that. Actually, one of the things it showed was I didn't need to bother. This was the last release before I joined the project, the one in which they decided that things were going seriously wrong and they needed some help. You can then see what happened afterwards. It gets so much better that you can say, okay, we don't need to worry about that. As long as that lump on the histogram stays small, we don't need to worry about exactly what it is. We just know it's good. If it gets any bigger, we'll start to worry. A quick word about this. I called it defect detection effectiveness. In their book on software test automation, Mark Fuster and Dorothy Graham call it defect detection percentage, which it is a percentage. The first time you'll find it in print is in Bill Hetzel's book, Making Software Measurement Work. I think that's the name of it. Is that, Hans, is that right? Making Software Measurement Work by Hetzel sometime in the 1990s? Something like that. He called it defect detection efficiency. That's not correct because it doesn't take account of resources. I call it defect detection effectiveness, but from now on I'll call it DDE because that's a lot easier and quicker to say. The other thing, of course, that I wanted to know was where the defects are, just in case there are any clusters that need to be investigated. That was actually from a different project, hence it's called severity rather than priority. The histograms represent functional areas within the product, and the color bands represent severity. But not all projects are the same. This was another situation where I was called in because people felt that some improvements were needed. Now, this was a software house in the financial sector, delivering applications with usually a standard core, but quite a lot of customizations around the edges for individual customers. They were developing new products with Scrum, but they were doing maintenance and odd custom change requests with Kanban. And this time, as soon as I got there, I realized I really had to know DDE. Because nobody knew what it was. In fact, I don't think anybody there actually realized there was such a thing. But they all knew it was bad because the customers were complaining. So I thought, right, we actually need to know what it is. We've got all these stories of, oh, it's terrible. No, it's not so bad. Oh, it's awful. Okay, measure it, please. Give me a number I can work with. So that was the first thing. But it was also very important to know what sorts of defects we were dealing with, which parts of the product they were in, what kind of defects they were, at what stage they got into the product, and at what stage in the life cycle they were found. I also wanted to know, because I had some almost immediate doubts about it, how good the defect reporting was, especially the defect reporting from the customers. So I wanted to understand the rejection rate, and I wanted to understand the accuracy of the data being recorded. But for reasons that I mentioned earlier, I didn't want to start measuring that until the story was said to be done. Once it got into regression, end-to-end testing and acceptance, then I wanted to know. And one of the first things I did was just take a look at priority and urgency. Now, I ought to explain now, we were using Jira. Jira comes with a default field called priority, which makes sense for most stories. And it was being used for bugs to mean severity, which was kind of confusing because I like the severity and priority system for bugs. But we decided it was a bit too confusing to change the name of this. So basically we kept severity called priority, and I introduced a new field called urgency to be priority, how quickly we needed to fix it. Now, as I'm sure you all know, and you'd expect, usually those two things stay in line, but there can be exceptions for political reasons, for operational reasons. A trivial bug is for some reason blocking testing or whatever. But I wanted a sanity check. I wanted to know, well, partly I wanted to know how bad the bugs were, but I also wanted to know whether this was really being reported correctly, because testers can exaggerate severity and customers often exaggerate severity. And one of the things that I noticed was that, well, the first thing I noticed was 40% of them were major in a 5-level scheme. And I had a look at some of them and I thought, that's not major, that's not major, that's not major. And of course, it wasn't coincidence that major was the default. So seeing that picture gave me a trigger. I changed the default to minor. And it won't surprise you to know that the next time I measured it, of course, there were more minor ones. However, this time when you checked against against a sample of the defect reports, you saw that this was a lot more sensible, because the people who really thought their bug was major were changing the default. And urgency gave me a good sanity check against that, because, as we know, usually they're approximately in line, and we do expect only a small difference. Then I wanted to know how good the individual bug reports were. And so I started looking at resolution. And I saw that the number of bugs that were rejected or unreproducible or duplicate reports totaled 9%. Almost all of those came from internal testing, not from the customer. And, well, I don't think any of you would be very happy with that, would you? So that was interesting, and it wasn't too hard to do something about it. Just a bit of training amongst the testers. And then there was something called fault source, which is really about what caused the bug, where the bug got in. Was it, in code, in a configuration parameter, a bad deployment, or data or something? But there was one that said no real fault, which was the one you used if it was a reject or unreproducible, or a duplicate. So, of course, if that was 9%, that should also be 9%. Oops, no, it's 11%. That told me that people weren't actually making these classifications accurately, and it wasn't too hard to guess that what was happening was that people were resolving duplicates and irreproducible ones as fixed, just because that was the default and it was laziness. So I could do something about that as well. I wanted to know what kinds of bug we were getting, because I wanted to know if perhaps there were a large number of usability bugs or a large number of performance bugs. And this wasn't overall. I was doing this by product. And I've mentioned fault source before. I genuinely wanted to know, and this time I've excluded the rejects. So these are the real bugs, and I wanted to know where these bugs got into the product. And I wanted to know what kinds of bug they were. Particularly, I wanted to find out if requirements were giving us big problems because things weren't being included or weren't being clearly explained. So I was having a look at that. Of course, I wanted to know where they were found, because that's how I can calculate my defect detection effectiveness. And I wanted to know where they were. Again, if there are any particular defect clusters that might need some investigation or some more testing, I wanted to see them. And now being able to calculate my defect detective, DDE, I could publish it. That went on a wiki page on the intranet so that I could name and shame the bad guys and praise the good ones. Now, I didn't do that until I discussed my findings with the project leaders, the architects, and the scrum masters. And behind every one of those was a page that included the sorts of graphs that I've shown before, with some interpretation that I'd done by discussions with the project teams as to what factors perhaps might have made one release much better than another, perhaps much harder to test than another. Now, let's go back to something. You might have noticed that after the priority and urgency slides, all of these pie charts have the word weighted in the title. This goes back to what I said earlier on about quantities aren't necessarily a good guide to what's happening. Yeah? 20% of our bug reports come from customers sounds horrible until you realize that actually they're only spelling mistakes. So does that mean you have to analyze each severity level separately? But then you've got 5 times as much work to do. Alternatively, you could just say, well, okay, I'll only bother with the top 1 or 2 severity levels. However, a very large number of trivial bugs might actually be a symptom of a serious problem somewhere. And if you're only looking at the top 2 severity levels, you will miss that. So, I use a weighted defect measure. I multiply the quantity of defects in each severity level by a weighting that I give that severity level from 15 for something really horrendous, to 1 for something really trivial, and 3, 6, 10 in between. So for those, 22, 30, 36 bugs, I end up with a weighted severity of 139. Which means that when I'm looking at one of those pie charts that I showed you just now, each sector is not a quantity of bugs, it's actually a measure of what I think of as the total amount of badness that we found. And what that means is that you can concentrate on the most important things and not get misled by the trivial ones. So, in summary, some things that might not be very useful in an Agile project. As mentioned earlier, how long it takes to fix bugs is usually not an issue on an Agile project. The number of defects that you find during the development of an individual story, again, for all sorts of reasons that I mentioned, it's not really worth counting. Requirement coverage, mentioned earlier. I think Elizabeth Hendrickson's absolutely right here. In fact, I think she usually is. I have great respect for her. But what we can look at, and I haven't mentioned this before, but unit test coverage is very, very important. So for that, we should expect the developers to be using a tool that will tell us, some kind of code coverage tool. But of course, it's not necessarily an indication of quality, but at least it is an indication of how much has been tested. For feature level coverage, lots of focus on release level regression tests. But then go down to whatever level of detail you need to below that. I'd say that usually just one level down is enough, according to the various functional areas of the system. And as a manager, I am much more interested in trends than in snapshot quantities. Because that tells me whether things are getting better or worse, and it tells me what things I have to investigate most urgently. Here's one that's, I mean, this isn't only about Agile, of course, but if you're developing anything that's got to run on a variety of different platforms or use a variety of different browsers, then you really need to know what your coverage is across the domain of things that your customers might want to run on. DDE is one of my absolute favorites. In fact, I don't know how you manage a testing operation without at least knowing if it's good or bad, and if it's not good, then you really need to measure it. And then the other sorts of analyses that you've seen. Where are the defects? Are there any defect clusters that need investigation or further testing? Because that could lead us to identifying process improvements. Knowing how good or bad our defect reports are can also give us process improvements and generally increase productivity, because the fewer bad defect reports we have, the greater the productivity of the team. And, well, no two projects are exactly the same. Individual projects might have special needs. Thanks.